We bring to you from Vyas Certification this portion of NCERT discussion, class 11th chemistry, and we are talking about a unit in organic chemistry. Yes, the very favorite, some basic principles and techniques of organic chemistry. It's a very conceptual, very fundamental, essential chapter of great importance in understanding the basics of organic chemistry. I repeat, doing it, studying it from NCERT for the first time can be suicidal. You may be quite misled into misunderstanding a number of concepts, but in case you have understood the concepts from an independent source, NCERT is a great place for revision, and because of the nexus between authorities, it makes it compulsory also. So let's start taking a look, and there comes your first question. What are the hybridization states of each carbon atom in the following compounds? Fascinating. And we have number of following compounds. CH2, CO, HCH, double bond C, double bond O. Let us not forget a simple table. And what is that? Okay, number of bonds formed, and this is element. In organic compounds, you would find if you have carbon would have 4 bonds and number of lone pairs on an atom. It's a very useful table. Please note. So carbon atom would not have any lone pair of electrons, but it would have 4 bonds. Like you can see, this carbon has 1, 2, 3, 4 bonds. Can you see that? This carbon has 1, 2, 3, 4 bonds. So carbon always tends to form 4 bonds only as long as there is no charge present on the atom, right? So this is uncharged. There is no positive or negative charge. In that case, carbon would form 4 bonds and no lone pairs. Nitrogen will form 3 bonds and 1 lone pair. Oxygen would form 2 bonds with 2 lone pairs, and all halogens FCl, Bri would form only 1 bond and they would have 3 lone pairs. This is true for all reasonable compounds in organic chemistry. Right? Perfect. We'll use this information. You're supposed to remember this table. You're supposed to have memorized this information. Using this, I'm trying to draw their full structures. This first molecule is called ketene. Sounds like kitty party. It's ketene. And then you have CH3, CH3, CH double bond, CH2. I've just drawn 2 compounds. There are 3, 4, 5. There are 2 more. Let me draw all of them actually so that you can take a good look at them. Then we have CH3, CH3, C double bond O, and then again we have CH3. Right? Lastly, last 2 compounds also. Let me just first solve them and then I'll go to them. Agreed? Fine. The first one. Now, how do I decide hybridization? For deciding hybridization also, there is a trick. And what is that? Just count the number of sigma bonds plus lone pairs. Sigma bonds plus lone pairs is equal to what we called as steric number. And between 2 atoms, please remember, there can be only 1 sigma bond. All the extra bonds are pi. So 1, 2 and 3, sigma, sigma and sigma. There is only 1 sigma bond each. So this carbon has 3 sigma bonds, right? And does this carbon possess any lone pair of electrons? No. So steric number is 3. And with every steric number, a hybridization is associated. So what would be the hybridization? Let me again give you a small chart. If you have steric number 4, 3 or 2, accordingly you would have hybridization sp3 or sp2 or sp. Wow, that's the way. That is the way, my dear. So what do we have? We have this carbon as sp2 hybridized. What about this one? Sigma and sigma. Only one bond is sigma. Please remember, these are pi bonds. Actually, the upper bond is pi bond. There is nothing called as upper or lower bond. You can choose any one of them. Any one of them is sigma, the other one is pi. We don't care about pi bonds. So for this carbon, if I count for this carbon, sigma bonds are 1 and 1, 2. Lone pair 0, the steric number is 2. This means that this carbon is sp hybridized. See, steric number 2 means sp. So we say this is sp hybridized. sp2 and sp. That goes, yeah, there goes your first question. What about propene? Let's take a look. 1, 2 and 3. sp2. Done? What about the other one? This carbon, 1, 2 and 3 again. Wow. So this also would be sp2, very much. What about the third one? 1, 2, 3 and 4. Wow. This is sp3? Yes, this is sp3. sp3, sp2, sp2. These are the hybridizations of each carbon atom. Let's take a look at the next one, the third one. The name of third one, actually, there's a common name. It's called acetone. Acetone. Yes, this is acetone. Lovely molecule. A very popular nail polish remover. In case you use a nail paint, it is used for removing old nail paint and as a thinner for nail paints in general. Very popular compound, sweet smelling. See this carbon, 1, 2, 3, 4. So this carbon is sp3. 1, 2, 3, 4. So this carbon also is sp3 hybridized. Can you see that? Yeah, we can. What about the other one? The middle one. 1, 2 and 3. That means it should be sp2. Steric number 3 means sp2. So this is sp2 hybridized. There we are. Got it? Got it. Let's draw 4 and 5 and see. We have H, C, H, double bond, CH, CN. Oh wow. And then we have C6, H6, the very popular benzene. H, H, H and H. This is the lovely benzene. And this is acrylonitrile. Common name, very popular compounds these are. How do we get the hybridizations? Not very difficult. All we need to do is look at this carbon again. 1, 2 and 3. 3 sigma bonds, carbons not normally, they don't possess lone pairs anyways. This is sp2. This carbon 1, 2, 3, again sp2. This carbon 1 and 2. Wow, it is just sp. Yes, it's just sp. What about these? In benzene, all carbon atoms are similar actually. 1, 2 and 3 bonds, and this is it. So this carbon is sp2. As a matter of fact, all the carbon atoms, this, each of these 6 carbon atoms is sp2 hybridized in benzene.